Hi, welcome to our dynamics problem presentation. This presentation is done by myself, Andrew Binning, Trung Do, and Matt Goins. Right here's a picture of our problem. We have a 5-pound block sitting on a plane, and that is connected to a 2-pound block that is 90 degrees from a pulley that is a 6-inch radius. The eye of the pulley is 0.4 slug feet squared, and the coefficient of friction between the 5-pound block and the surface is 0.2. For our problem, we have to solve for the angular velocity of the pulley and the velocity of the 2-pound block at 5 seconds.
Hi, I'm Matt. So for the first step of the solution, we need to find the tension in the rope. And to do that, we need to draw the FBD of both blocks. So for this one, we drew it, and we have the weight of the first block, the 5-pound block, going down, the normal force pushing back up. We have the frictional force due to the static coefficient, and we have the tension in the rope. So if you draw the sum of the forces in the X, you have the tension minus the frictional force. And to get the frictional force, you need the weight times the static coefficient. So you have T minus 5 times 0.2, which 5 times 0.2 is 1. So then you can set up your linear impulse momentum formula, which is mass times the velocity at 0.1 plus the integral from 0 to 5 times the force, and it equals the mass times the velocity too. So since we're in English units, I have to take the weight over 32.2 times the first velocity. Since it started from rest, it's at 0, or it equals 0. And then the force, which we found earlier, T minus 1, equals the mass over times velocity 2. And we get this relationship, that's 32.2 times T minus 1 equals the velocity at 0.2. And we have 2 unknowns, so we need another equation. So we come over here and we do the FBD of block 2, and we get the sum of the forces in the Y equal the weight minus the tension, which equals 2 pounds minus T. And we set up the linear impulse momentum again, and we get 0 plus 5 times 2 minus T equals the mass of block 2, which is 2 over 32.2 times the velocity at 0.2. And we get 5 times T minus, or 2 minus T equals 2 over 32 times Vg, which we got here. And you substitute that in, and you get T equals 12 over 7 pounds, or 1.71 pounds. Now that we got our tension, we can plug the tension back into our relationship we found at first, which was the velocity at 0.2 equals 32.2 times T minus 1. And when you plug it in, we get the velocity of block 2 to be 22.862 feet per second.
I'm Trung Do. I'm going to take the last part of the problem. Look at the fifth body diagram. We have a pulley, and the T go down with the radius is 6 inches. Apply the angular momentum relationship. We had I. We already know W1 0 at the rest, and we have to find W2, and the momentum equal the tension time with distance. Distance is the radius of the pulley, and we plus all the number we get from the previous part, and we get the W2 equal 10.71 radius per second.
Okay, so to wrap things up, we found that the velocity of block 2 is 22.862 feet per second going down, and the angular velocity of the pulley is 10.71 radians a second in a clockwise rotation.